As you can see here, we have 4 different tables of output. We'll walk through each of these in just a moment. So beginning with the variables entered removed table, this isn't very critical in simple regression. We can just quickly look at it to make sure things look right. Notice it says here the dependent variable is college GPA, and the variables entered here is just one, high school GPA. The key here is that we have our dependent variable of college GPA, which is what we want, and this is the independent variable. So this looks good. Next we have our model summary table, and we're going to spend a few moments on this table. And there are a couple important values here in the model summary table, namely R and R square. We'll talk about each of these next. In the model summary table here, R is known as the multiple correlation coefficient. Now in simple regression, where we just have one independent variable, or X, it's really just equal to the Pearson correlation. And in fact, 0.807 is the correlation between high school GPA and college GPA. Next we have our model summary table. And in the model summary table, there's 2 values that we want to talk about. That's R and R squared. R is known as the multiple correlation coefficient. And in simple regression, where we just have one independent variable, it's equal to the Pearson correlation. So in other words, this value of 0.807, it's simply the correlation between high school GPA and college GPA. Next, R squared is equal to 0.652 in this example. And the definition for R squared is that it's the amount of variance in the dependent variable that is accounted for or explained by the independent variable. So what we do to interpret this is we take our 0.65 and we can turn that into a percentage. That's one way to talk about it. So if we take 0.65, convert that to a percentage by multiplying by 100 and then adding the percent sign, that means that gives us 65% first of all. And that means that high school GPA explains 65% of the variance in college GPA. Okay, so that's what R squared means. It tells you the amount of variance in the dependent variable that is accounted for or explained by the independent variable. And this can be a little tricky at first to kind of try and get your head wrapped around this, what exactly that means. 65% of the variance, what does that mean? Well, if you think of the variance of our dependent variable, college GPA, if it's represented by a circle, and that circle could be a pie or a pizza, and if you think 65%, if we call that 2/3, just to round it, if we took 2/3 of that pizza or 2/3 of that pie, that's how much, in terms of the variability in the college GPA scores, the variability in those values, we can account for or explain, or another way to think about it is we can predict essentially 65% of that, or almost 2/3, which means we cannot account for or explain, or we cannot predict about 1/3, or more precisely 35% of the variance in college GPA. 35% of it we have no control over, but the other 65% we can completely explain by knowing high school GPA alone. And that's actually quite good in regression. Okay, so that's it for R and R squared. Next, let's move on to our last 2 tables, ANOVA and coefficients.